Welcome back to section 1.7. We're still talking about our transformations. So we're going to graph our parent function for number 17, f of x equals x squared. So for our parent function, 0, 0, 1, 1, 2, 4, 3, 9, negative 3, 9, negative 2, 4, negative 1, 1. Now, looking at our values, we have nothing in front, nothing inside as far as shrink or stretch, either horizontal or vertical. What we do have is that h equals and k equals. So h is negative 3, k is negative 2. So that means we're going left 3 and we're going down 2. So we're going to take each point and go to the left 3 and down 2. So left 3, down 2. Left 3 down 2, 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 left 3 down 2. And there's our points. So we'll draw the graph through those points. So we've got our shift right here. Now our domain. All real numbers, so it's negative infinity to infinity. Our range is going from negative 2 to infinity, so a bracket at negative 2 up to infinity. All right. Now, problem number 17. Our parent function still remains the same. It's a quadratic, 0, 0, 1, 1, 2, 4, 3, 9, and then the negatives as well. So now we have that leading coefficient of negative 1/2. I'm going to call that A. H is 1 and K is 4. So for our transformations, we have a vertical compression because of that 1/2. Now, not only that, but we have, because of the negative, we have an x-axis reflection. So we have both. Then we're going to shift to the right 1, and then we're going to go up 4. So there's a lot going on. Now, what we can do is we can do that vertical compression and the x-axis reflection all at one time. So what we're going to do is we're going to multiply each y value by negative 1/2. 0 times negative 1/2 is 0. 1 times negative 1/2 is negative 1/2. 4 times negative 1/2 is negative 2. 9 times negative 1/2 is negative 4 and 1/2. And there's our values. Now, what we want to do after that is that took care of our compression and reflection. Now we want to shift everything to the right 1 and up 4. I'm going to use an open dot here just to kind of differentiate. Over to the right 1, up 4. To the right 1, up 4. To the right 1, up 4. And there is our graph. I know it gets a little bit messy with all the little points, but there's our graph. Now our domain is still all real numbers. So we're going from negative infinity to positive infinity. And our range, we're going down from 4, so smaller to larger. So we're going from negative infinity up to and including 4, so we're going to put a bracket at the 4. Number 19. There's nothing on the outside, but on the inside we have that negative. So with that negative on the inside, that means we have a reflection along that y-axis because it's an inside negative. It's inside the function itself. H is 1 and k is 2. So now we have a reflection along the y-axis, and we also have to shift to the right 1, and we have to go up 2. So I'm going to graph my parent function, my anchor points for a square root function, 0, 0, 1, 1, 4, 2, 9, 3. And now what we're going to do is we're going to multiply each value of x by -1. So when x is 0, y is still 0. When x is 1, we're going to multiply that by -1. We're at -1, 1. 4 times -1, so we're at -4, 2. 9 times -1, we're going to be at -9, 3. And now we're going to shift all of our points to the right 1 and up 2. So we're going to right 1, up 2. We're going to use an open dot differentiate. To the right 1, up 2. To the right 1, up 2. To the right 1, up 2. And here is going to be our graph of that square root function. So our domain, our highest value for x is 1. So even though there's an open dot, it's still a solid dot there. We're going to go from smaller to larger, -infinity to 1 with a bracket. Our range, we're going up from 2. So it's going to be with a bracket 2 to +infinity because it's going up. And there we go. There's our transformations and our domain and range. Now for number 20, it's very similar, except we have that 3 on the outside. So with that 3, there is a vertical stretch of 3. The negative on the inside, we have a reflection along that y-axis. And now we're going to shift up. Shift to the right 1 and up 2, just like we did in the last one. The only thing different here is that we have that 3 added on. So what we're going to do, anchor points, same as before. Now we're going to, we'll reflect along that y-axis. Same points before I did any shifting. Now I'm going to erase those points just so I can not confuse myself too much. Now I'm going to stretch vertically by 3. So I'm going to multiply each value of y by 3. 3 times 3 is 9. 2 times 3 is 6. 1 times 3 is 3. 0 times 3 is 0. And now I'm going to take each point and go to the right 1 and up 2. Go to the right 1 and up 2. Go to the right 1 and up 2. And go to the right 1 and up 2. And there is my graph through those points. Much different looking than the last one. You can see it's kind of just stretched vertically 3. It's getting much taller. So our domain is going to go from -infinity to 1, just the same as it did before. Our range, same thing. We're starting at 2 and going towards infinity. So it didn't affect our domain and range. The graph is just stretched vertically. And the next two are a little bit more complicated. These are going to have some things going horizontally. So for number 21, we have that number on the inside, that 3. So now what we have, and what seems counterintuitive, is that with that 3, we have a horizontal shrink or a horizontal compression. And that shrink is 1/3 of 1/3. Now, what it is that it's x divided by 3 is the same as 1/3 x. So to find that, what you're going to be doing is dividing x by whatever that number. So x divided by 3 is what, 1/3 x. So there's that compression, that shrink. Now, we have an h value of 0. There's nothing in the parentheses, and a k value of -2. So what we're doing is we have that horizontal shrink of 1/3, and we're going to shift down 3. So with my square root function, here is my anchor points, same as we did for the last two problems with the anchor points. Now, for our horizontal compression, that horizontal shrink, we're going to multiply each value of x by 1/3. 0 times 1/3 is 0. 1 times 1/3 is 1/3. 4 times 1/3 is 4 and 1/3, or 4/3, which is 1 and 1/3. And 9 times 1/3 is 3. So you can see we squeezed all of those values for x much closer together. And now we're going to take each point and we're going to go down 3. Down 3. Down 3. Down 3. And down 3. And there is our graph. Those are much trickier. So our domain, we're still starting at 0 and going towards infinity. Bracket at the 0. And for our range, our lowest value is negative. Oh, sorry, that's down 2. So kind of ignore that. Just move everything up. It's going to be from 2 to infinity. Sorry about that. All those should be moved up. So it should be here, 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 and here. Thankfully, it's not a major difference, but still should be correct. Now for 22, big asterisk next to this one. This one is a mess. Because if you look at how these functions are written, we want grouping symbols on the inside. So we need to rewrite this function. F of x equals the square root. Now what I'm going to do is I'm going to factor out the 1/2. So it's 1/2, and when we do that reverse distributive property, it's going to be x. And then 2 divided by 1/2 is actually a 4. So it's 1/2 the quantity of x plus 4. So that value on the inside, that 1/2, once again, it's counterintuitive. Because what it is, it's x divided by the 1/2, which is x times 2, which is 2 times x. So we have a horizontal stretch. And then h is -4, and there is no value for k. So you can see we even changed our value for h. It looked like it was going to be a 2, but when we factored out that 1/2, it's actually a -4. So then we're going to have to shift left 4. So we'll plot our anchor points as we've been doing. Same thing as the last 3. Now we're going to do our horizontal stretch. I'm going to multiply each value of x by 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. That's way off the graph. And then we just take each point and go to the left 4. And we're going to draw our graph through those points. So our domain, starting at -4. So we have a bracket at -4 up to infinity. Range, we're going to be going from 0 to infinity. Bracket at the 0, parentheses at the infinity. So those last two are tricky. The horizontal stretching compressions are very tricky. So keep that in mind and be on the lookout for them. Make sure you factor out if you don't have grouping symbols underneath or in your function itself. Okay, we'll keep practicing those, and I'll see you in the next video.